Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math, and this is another session of Tutor Me Senpai. Welcome back, everyone. I'm Courtney, and this is another session of Tutor Me Senpai. Today we're going to be jumping into a 6th grade topic, adding unlike fractions. Now, if you're unsure what an unlike fraction is, that is just another term for adding two fractions that have different denominators. Before we jump into our question today, I want to give you another reminder that if you have any questions about what we see here, or even some of your own homework, why don't you visit me on Facebook at Tutor Me Senpai. You can leave me your questions, concerns, or maybe even your own homework if you would like to see a video on it here. Without further ado, let's jump into our question for today. So our question for today is 6 over 11 plus 2 over 3. Now, if you know how to handle adding fractions in general, you know that adding two fractions together requires them to have the same denominator. Now, in this case, you keep the same denominator and you add across. But this is only possible because the denominator is the same. But what happens when you have two denominators that are not the same? Here we have unlike fractions. Well, we have to do a little bit more work, and we're going to ultimately get it to where they are the same, but before we can add things, we have to manipulate how they look. Adding unlike fractions is going to require us to look at something called the LCM, or least common multiple. What that means is we're going to list out all the multiples of 11 and 3, or at least a good number of them, until we find something that they match on. Now, we already know what we can do to find a guarantee match, but the least common multiple wants us to find the smallest such match. In order to find that guarantee match, you can always just multiply the two numbers together, and that's going to be what they have in common. 11 times 3 is going to be a common multiple for 11 and 3 since they're multiplied together. However, we don't know if that's the least common multiple. If there's something smaller, we want to choose the smaller one rather than going with the more convenient one. But if there is nothing smaller than 11 times 3, then we are free to use that one. So before we can make up our minds, let's find out the different factors of 11 and 3 and see if they do have something smaller that we can use outside of 11 times 3. So what I like to do is, I like to use the larger number and then go up to whatever the multiple would be if you multiply the two denominators together, and that's going to give us our ending point. If we don't find something smaller by the time it gets to what they have in common by multiplying them together, then that is going to be our common denominator. So since we have 11 times 3 as the largest common multiple that we would be comfortable using, we're going to put 3 spots here. So 11 times 1 is going to give us 11, 11 times 2 is 22, and 11 times 3 is 33. So we don't need to worry about 11 times 4 because we know that at the very least, they're going to have this in common. We don't have to pay attention to anything else. At the very least, they're going to have this in common. But we want to know, do they have anything smaller in common? So you can do the same thing for 3. If you have space, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9, 3 times 10, 3 times 11. So we know that they have this in common, right? We're stopping at the endpoints where we would feel comfortable without going and trying to find more, because we know we can stop at the very least at 11 times 3, the two denominators multiplied together. Now let's see, do they have 11 in common? If we look at the multiples of 3, do you see 11 here? Is 11 a common multiple with 3? No. We have 12 and we have 9, but we don't have 11. So we don't have 11 there. Now let's look at 22. Is 22 common between the two? No, we have 21 and 24, but we don't have 22. So if the first three multiples of 11 are 11, 22, and 33, and we know that we definitely have 33 because that's the result of multiplying the two denominators, but we don't have anything smaller for 11, that means this is the least common multiple for both of these numbers. They don't have anything else in common besides what they have when you multiply them together, as far as small numbers go. Now, if you continue, there'll be more that they have in common. But once again, we're trying to find the smallest, the least common multiple between the two. So now that we have the least common multiple, and we know it's 33, let's clear off the board a little bit to give us a little bit more space to work with, and I'll show you how this least common multiple is going to play a role in our question. So now that we have 33 as our least common multiple, that's going to tell us that we want to have two fractions ultimately that look like this. Something over 33 plus something else over 33. But how do we get this without changing our question? Well, that's easy. As long as whatever we do to the numerator, we're also doing to the denominator and vice versa, we are not going to change the question, but we're going to change how it looks. In order to get 33 in the denominator, what do we have to multiply the denominator by? Well, that's going to be 3, right? 11 times 3 is going to give us the 33 in the denominator that we're looking for. Now, once again, we don't want to change our fraction. So what can we multiply by anything to get itself? So if we're multiplying 7 times something and it equals 7, what is that something? It's a 1. So if we want to multiply 6 over 11 times something, and we don't want the 6 over 11 to change, we need to multiply it by 1. But we have a 3 in denominator. So how do we make sure that whatever we're multiplying equals 1 if we have a 3 in denominator? That means we have to have a 3 in the numerator. Anything over itself gives us that 1 that is not going to change this, but it's just going to change its appearance. The actual value is the same because we're just multiplying by 1, but the appearance looks different. So this is going to be 18 over 33. And once again, I said 3 over 3. We chose that because the denominator needed to be multiplied by 3, and we wanted to make sure that this whole fraction doesn't change, so we have to put a 3 also in the numerator. And by doing that, we're actually just multiplying by 1, but we get a new looking fraction. It's the same fraction, it just looks different. And because it looks different, we get to actually use it in addition as far as this fraction or this equation goes. So this 18 over 33 is going to be our first fraction. Now let's look at the second fraction. We have a 2 over 3. Now what do you have to multiply by this denominator, 3, to get 33? Well, that's 11. And remember, we're also wanting to make sure we're not changing our fraction. So in order to not change the fraction, although we're multiplying, we have to multiply by 1. How do we get 1? How do we make sure that this fraction is going to equal 1? We have to put whatever's in the denominator also in the numerator. 11 in the denominator and 11 in the numerator means that when we divide this, it equals 1. So we're not changing, once again, we're not changing the fraction value, we're changing how the fraction looks. And this equals 22 over 33. So this will be our second fraction. So now that we've gone from this, which we couldn't add because they were unlike fractions, to this, which we can add now because they are like fractions, hence the like denominators, we can finally find the answer to this question. So 18 over 33 plus 22 over 33, once again, adding like fractions means that we keep the denominator and we're adding across the top. Well, what's 18 plus 22? That is 40. So the answer to this question is 40 over 33. Normally, I would recommend when you find your answer in this fashion, see if you can simplify this anymore. So that concludes another session of Tutor Me Senpai, where we tackled a 6th grade topic, adding unlike fractions. And that's just another fancy way of saying adding two fractions that have different denominators. Your fractions need to have the same denominators in order for you to add them, so when you're tackling unlike fractions, you have an extra step you have to do before you can actually add them. I hope today's video was easy for you to follow. If it wasn't, don't worry. I challenge you to watch the video again and again and again and practice alongside me. Pause where you need to, just to make sure you understand where I'm trying to tell you. I promise you that with much practice, you will eventually get it, and you'll be more prepared to tackle those harder questions that have those more difficult looking fractions later on. If you have any questions about what you saw today, leave them in the comment box below, or once again, you can visit me on Facebook at Tutor Me Senpai. You can find a link in the description below. If you found this video helpful, why don't you leave me a like? Hit the subscribe button and the notification bell so you can be informed every time I drop my next video. Well, that's all the time I have for today. I really hope this helped with your homework, and I look forward to seeing you again next time. I'm Courtney, and this is another session of Tutor Me Senpai.